Hey everyone, we are continuing with our volumes here, and this time we're mixing it up a bit. Before, every time I did a volume, it was something rotated, and so you were dealing with like circles or washers, that is a circle with a hole in it. So this time, say we have this chunk of wood that's 2 by 2 by 4, and if we were to cut along it, like cut a slice off, following the path of this 4 minus x square rooted, the shape we would get is like, like the top gets planed off of sorts. And this is where things get really weird to draw. Warning there. So say we do this cut. So basically what we have here is like, if you imagine here's your block of wood, you can see the curve superimposed on that. I'm going to see if I can draw this. It will probably come out badly. I even made a little pattern just to help myself out a bit. So like if I go across from the top down to the right, so I have something like this happening and also on the front edge, and I should have done that in something like that. So if you imagine that getting cut off. So then if we do a second cut, following this exact same pattern, but this time I'm going to go along vertically. So it would be something like, if you imagine putting this as a whole block together, it's kind of like flipping this over and repeating it. So, and this is where it gets a little harder to visualize. Say I went like this across the front edge if it were all there. And you're probably looking at this drawing and you're like, what the heck does this look like? Well, basically it looks like this, and I'm going to darken this a bit because it's kind of hard to see. So it's kind of a, I don't know what shape. So what we have here along this back blue, that back line on the blue is just that original 4 minus x square rooted. And then that's the same on the bottom. And then this green is kind of the top left to bottom right diagonal-ish thing. And this is still probably hard to visualize. There is actually a drawing of this in section 5.9 of our book. So visualizing these is really, really hard. It's easier if instead of trying to visualize the whole thing, just look at one single slice. And that one single slice, if I go to my original, just that original graph, if I draw in a sample rectangle, just like we did with our areas. So if I look at that sample rectangle, and that's the basis of my slice. So if I go like that across, so down like that's down the back, and then here's across the bottom, here's up the front, and then across the top. So the shape I have here, looking at that, you can kind of visualize it a little more. The thickness of it, just like here, this thickness is dx. This height is y, which is that 4 minus x square rooted. And I know I'm saying that totally wrong, but you know what I mean. Okay, so across here I have the y. And I did the same thing across the bottom. So this is also y. So basically I have this square that's y by dx. So anytime you're doing a volume, it doesn't matter the shape, it's actually going to be the same technique. And this is going to sound weird that it's the same technique, but it's, if this is a slice of bread, it's the area you have to spread your peanut butter or whatever you like times how thick it is. And how thick it is always dx or dy. So again, it's always like the area of the slice times the thickness of the slice. So if you're thinking about it like a piece of bread, it's the area you have for spreading whatever you like times how thick it is, and the thickness is always going to be dx or dy. So in this case, the area being a square is going to be y times y or y squared. And then the thickness dx. And then to get the entire loaf of bread, I'm going to stick with the bread analogy because it's super convenient, we integrate it. So we integrate for our bounds, looking back at the original function. I'm going to slide up for a moment. X goes from 0 to 4. So there's my bounds. So I have the integral from 0 to 4 of y squared dx. Okay, that dx, of course, is in charge. It tells me I need to have everything in terms of x. So y is equal to the square root of 4 minus x. It's getting squared times dx. We're going to integrate from 0 to 4. Okay, one thing to note, just as a quality control thing, looking at this original block that's 2 by 2 by 4, the volume of this guy is 16 cubic units. So we know that our answer better be less than 16 because of the original block being a volume of 16. So cleaning this up before integrating, we just have a 4 minus x in parentheses dx from 0 to 4. Integrating that, we get a 4x minus 1/2 x squared from 0 to 4. Remember your proper notation with those vertical bars. And then we can follow the fundamental theorem. Plugging in the 4, we get 4 times 4 minus half of 4 squared minus, I'm throwing the 0 in just as a nice little reminder, it's 4 times 0 minus half of 0 squared. So we have 16 minus half of 16, which is 8. Exactly. So how cool is this? We have this wonky, weird shape that's been, we've taken a square root and cut a square root across the one side of a block. We flipped it. We did the same cut again. I really wish I had a wooden model of this. I usually use Play-Doh and model it with a cheese slicer, but I don't have any Play-Doh, and I also don't have 2 working arms. So, just wouldn't work. But how cool is it that doing these slices, we ended up with exactly 8, half the original volume. It's just kind of fun. But here's our main technique that we have to consider though. No matter what, if it's a square like this, or if we have a washer, with a circle with another circle taken out of it, or whatever it is, it's always just, what's my space for my peanut butter times how thick my slice is. That's going to be the method every single time, no matter what. Area of the slice times the thickness of the slice. We'll have a second example showing another shape just to give you another go at it. But that's really the technique to keep in mind. If you don't try to visualize the entire loaf of bread, just say, I'm reaching into the bag, I'm pulling out one slice. How much do I have for my peanut butter? And then times how thick it is and integrate. That's the technique.